Hello friends, today we will be trying to find out the load carrying capacity of a pipe based on dynamic formula. In previous video you have seen how to find out the load carrying capacity of a pipe by using a static formula, by using penetration test data or from pile load test. So similarly you can find out the pile load carrying capacity pile load carrying capacity based on dynamic formula. So from a static formula we have already seen how to find out. You can find it out. This we have already seen. You can also find out the pile load carrying capacity based on penetration test data. You can carry out SPT, standard penetration test, and based on N value, you can predict the load carrying capacity of a pipe. This also we have done it. We can also find out from pile load test. Pile load test. So how to find out the ultimate load carrying capacity of a pipe. This we have also seen it. So these are all done in previous videos. So today our focus is on dynamic formula. So if you have a pile, this pile is embedded into the ground. And you want to carry out the dynamic test. So you will have to put here helmet over it. So you can put the helmet. You can put certain elastic material, and this helmet you can have a hammer. With the hammer, the weight of the hammer is WH. This falls from a height capital H, and it is going to have an impact over the pipe. So this is the pipe. Then you can apply the dynamic formula. So depending upon the weight of the hammer, how much is the total energy that's being imparted to. So if the weight of the hammer is WH, if you multiply it by the height of fall, capital H, as shown in the figure, multiplied by, there is the energy, multiplied by efficiency of the hammer, eta H. So eta H is the efficiency of the hammer, how the hammer is going, whether you are having under gravity it is going to, or you are going to have some steam, single acting steam or double acting steam, and this is being operated. So how you are going to operate it? So based on that, the efficiency of the hammer. So this is equal to, this is the total energy that you are imparting to this pile, and the pile is going to set. So this is equal to the ultimate load carrying capacity of a pile multiplied by set. So this is the set per blow plus some energy losses will be there. Energy losses. So based on this principle, many people have worked out, many researchers, they have given some formula. Way back in 19th century, 1886, Mr. Wellington has given one equation which is very famous, known as engineering use formula. So based on this, you can find out the capacity of the pile, the ultimate load carrying capacity of the pile can be found out. So you can see QU is the ultimate load carrying capacity of a pile, small s equal to set per blow, and WH is the weight of the hammer, (10 to 20 tons of hammers are very normal. H is the height of fall of the hammer. This hammer is going to fall down over the helmet, which has got the elastic pad, etc., so that the pile top is not broken down because it's made of precast concrete. So if you are going to directly hit it, your pile will get distorted, it will get having cracks. So you will have to put helmet. Like when we ride motorcycle, we put our helmet so that in case of any casualty, there is no impact and impact can be minimized. So here, to save the pile, we have to put the helmet, etc. So based on this, the first person who worked on this in 1886, he gave engineering use formula. So the first person gave engineering use formula. This formula is given by Wellington. Way back in 1886. And he gave that the allowable load carrying capacity QA, A for allowable load carrying capacity of a pile, can be given as weight of the hammer into height of fall of the hammer divided by a factor of safety into the set per blow plus a elastic compression C. So capital C over here, where factor of safety is here 6.0. So this can be written as W H divided by 6 S plus capital C. This is given by Wellington. So allowable load, this is called allowable load carrying capacity, load carrying capacity of a pile. You can use this, and this C can be taken as 2.5 centimeter. This is the elastic compression in centimeter. So 2.5 centimeter for free fall hammer. So under gravity it is going to hit the pipe. So if you are going to use a steam hammer, if it is single acting or double acting steam hammer, this value becomes 0.25 centimeter. For single oblique double acting steam hammer. So you can substitute the value, and S is the set per blow, because once you hit the pipe, it is going to undergo settlement, undergo the displacement, and that is called the set per blow. So you can take 5 blows for gravity hammer. If it is going to fall freely, or 20 blows for steam hammers. So total set, and then you can average it out, so you can get per blow. So that you can substitute it and get the allowable load carrying capacity. So this is called engineering news formula. So we can find it out this. There is another formula that is given by Hilley's, known as Hilley's formula. So another formula is known as Hilley's formula. So here the allowable load carrying capacity QA is given as weight of the hammer WH into height of fall of the hammer H into efficiency of the hammer blow eta H, efficiency of the hammer into eta B, efficiency of the hammer blow, divided by set S plus elastic compression divided by 2. So this equation is widely used, and it is given in IS 2911 part 1. This formula is also given in that. So here the weight of the hammer will be known to you, height of fall will be known to you, efficiency of the hammer blow is given in the IS 2911, and the value of eta H for gravity hammer it is going to be 1, and for single acting steam hammer it will be 0.75 to 0.85, and for double acting steam hammer it is going to be 0.85. So the value of eta H, efficiency of the hammer, its value is going to be between 0.75 to 1. So you can refer this, and tables are given, you can always use it. Then the this is eta B. Eta B is the efficiency of the blow, hammer blow. When you are hitting it, then what is the efficiency of the blow? How much energy is being transferred to the pile? That is the efficiency of the hammered blow, and the formulas are given in the tabular form in IS code. It depends upon the coefficient of restitution. So I will just give you how to calculate this value of eta B. If you find that the weight of the hammer is greater than the coefficient of restitution into weight of the pile. So WP is the weight of the pile and CR is called coefficient of restitution. This coefficient of restitution values is going to be between 0.25 to 0.55. So what is coefficient of restitution? It depends upon the material from which the pile is made. Say it is made of mild steel, then how much velocity is being transferred is going to be of higher order. If it is made of wood, the coefficient of restitution is going to be on the lower side. So the velocity when it is going to hit it, what is the velocity? And when the hammer is being lifted up, what is the velocity of the pile? So this ratio is called the coefficient of restitution, and its value, as I told you, is between 0.25 to 0.55. So if the weight of the hammer is greater than CR times weight of the pile, then the value of the efficiency of the blow can be taken as the value of weight of the hammer plus CR square weight of the pile divided by WH plus WP. How will you find out the weight of the pile? Weight of the pile can be calculated very easily if you know the diameter of the pile, and if you know the density of the pile material, you can easily calculate the weight of the pile. And coefficient of restitution being known to you, and if you find the weight of the hammer is more than this, then you calculate this eta B from this formula. So this formula can be easily used. If it is otherwise, say the weight of the pile, weight of the hammer is less than CR times the weight of the pile, then the value of eta B is going to be this minus WH plus CR WP divided by WH plus WP whole square. So this is minus. So this equation can be used if it is going to be less than CR times WP. So you can calculate efficiency of the hammer blow is already from the tabular table you can refer. This you can calculate by using this formula, and the set already you know per blow and C is elastic compression. So what do you mean by elastic compression? The value of C is the elastic compression, total elastic compression. So this is total. So here you have a elastic compression of the hammer. So this is equal to elastic compression of the helmet plus elastic compression of the pile C2 plus elastic compression of the soil C3. So this is for helmet. This is for pile material and this is for soil. And the sum total is going to be the total elastic compression. You substitute it over here and you will be able to find out the allowable load carrying capacity of a pile. And suppose you are going to have a single acting or double acting steam hammer. So for a steam hammer, what you can do it, that the allowable load will be WH plus the area of the piston into what is the steam pressure. You add up, multiplied by H, divided by here you will have to give the factor of safety also, because it is allowable load. So you will have to give the factor of safety in this equation. This factor of safety is 2.5. So in Hilley's formula, the factor of safety is going to be quite less. In engineering news formula, the factor of safety was 6, which is 2 to 2.5 if you are going to use Hilley's formula. So this is more reliable, and therefore in IS code it has been prominently quoted, and you should use it. So I have completely explained you how to use Hilley's formula. But for a steam engine, what you will have to do it, you will have to WH plus whatever is the load coming due to a steam pressure, that is to be added, and then factor of safety into S plus C. So here what you are going to do is the area of the piston in cm square, and the pressure P is the steam pressure, which is in kg per cm square. So A into P you will be getting, and this is the weight of the hammer in kg, and then you multiply, that's the total energy that you are going to give it. So divided by factor of safety. You can just do it here also. You can do it in engineering news formula. So if you are using a steam hammer for steam hammer, this term is going to be added up, and you can find out the allowable load carrying capacity. So thank you very much. This is what I wanted to do it in this.